Our topic for today is all about polynomial equations and the rational root theorem. So first, let's define what rational root theorem is. So if the polynomial p of x is equal to axn plus bx raised to n minus 1 plus wx plus c, where a is not equal to 0 and z is not equal to 0 has rational roots, then the roots must be in the form plus minus factors of z all over factors of a in lowest terms. So let's start with our example. So we have to determine the rational zeros of 3x raised to the 4th power minus 10x cubed minus 24x squared minus 6x plus 5 is equal to 0. So the possible roots are positive negative 1, positive negative 5, positive negative 1/3, and positive negative 5 over 3. So how were we able to determine these numbers? So this came from our previous slide, which tells us that we need to find the value of a and value of z, and then find their factors. And from their factors, we will put it in the fractional form. So this is a and this is z. So the factors of 3 are 3 and 1, negative 3 and negative 1, while the factors of 5 are 1, 5, and 5, negative 5, and negative 1. So z is in the numerator, so we have 1, 5, 1, 5, and a is in the denominator. So we have 1, 1, 3, 3. Don't forget the positive, negative sign. So 1 over 1 is 1, 5 over 1 is 5, 1/3 is 1/3, and 5 over 3 is 5 over 3. I hope you were able to understand it well. Now let's go on to the next slide. We need to use 1 to find out if it is a rational zero of the equation. So we will be using synthetic division. So 1, 3, negative 10, negative 24, negative 6, and positive 5. So bring down the first one, multiply 3 times 1 is 3, and then add negative 10 plus 3 is negative 7. Do the same thing for the next set of numbers. As you can see, we have a remainder of negative 32. For 1 to become a rational zero of the equation, the remainder should be 0. Therefore, 1 or positive 1 is not a rational zero of the equation. Next, let's use negative 1 and use synthetic division. We will be doing the same procedure. For this equation, our remainder is 0. Therefore, negative 1 is a rational zero. Take note of these numbers because we will be using them in the next page. So for this one, let's use 5 in the depressed polynomial. So what is the depressed polynomial? So these are the numbers which are our answers in the previous page, which are 3, -13, -11, and 5. It's okay to not put 0 in the end. So divide everything by 5. So since the remainder is 0, we will consider 5 as a rational zero of the equation. So we have 2 already, which is -1 and 5. Don't forget also our new depressed polynomial, which is 3, 2, and -1, because we will use it here in our next slide. So we have 3, 2, and -1 divided by 1/3. 3. 3 times 1/3 is 1. Since our remainder is still 0, 1/3 is a root of the equation. So since the depressed polynomial is now a linear equation, we can equate it to 0. So how would we know if it's a linear equation already? If there are just two numbers which are not equal to 0. So we have 3 and 3, which is equal to 3x plus 3 equal to 0. Simplify. So the last value of our x is -1. So our values are x equals -1, x equal to 5, x equal to 1/3, and x equal to -1 again. If you were asked to find the factors, you would be writing this as x plus 1, x minus 5, x minus 1/3, and x plus 1. So you just have to change the sign of the roots. So that would be all in finding the roots of the rational equations. And I hope that you learned something new.